In 26 through 33, for each statement in the referenced exercise, write the contrapositive, converse, and inverse. Indicate as best as you can which of these statements are true and which are false. Give a counterexample for each that is false. So here I have from the textbook the definition of the contrapositive, the converse, and the inverse. And you can see what you have to do in terms of negations and orderings of the implication. So the contrapositive, you swap the order and you negate each P and Q. For the converse, you just swap the order, and for the inverse, you just negate each component. So number 19 is a universally quantified statement and an if-then statement. So let's write down the contrapositive, converse, and inverse. Starting with the contrapositive, we keep the quantification the same. For all n that's an integer, so the first part is not q of x, which in this case, it would be not q of n. We have to negate the conclusion here. We have to negate specifically n is odd or n equals 2. And when we're negating the result of the OR operation, we have to use De Morgan's law. And so this negation would be if n is even and n does not equal 2, then n is not prime. So that's the contrapositive. For the converse, we're also going to have for all n that's an integer. In this case, we just swap the ordering of P and Q. So we would say if n is odd or n equals 2, then n is prime. And last, we have the inverse. For all n that's an integer. With the inverse, we just negate each component, but we keep the order the same. So if n is not prime, then n is even and n does not equal 2. So now the question is which one is true and which one is false. So the original statement, if n is prime, then n is odd or n equals 2, that's true, which means that the contrapositive is true, since the contrapositive is logically equivalent to the original statement. The converse says, for all n that's an integer, if n is odd or n equals 2, then n is prime. This is false because we can consider the case when n equals 9. In this case, n is odd or n equals 2 is true, then n is prime. That's not true. 9 is not prime. As for the inverse, usually the same counterexample works. We can look at n equals 9 and see that 9 is not prime. That's good. Then n is even and n does not equal 2. That's not true because 9 is not even. 9 is odd. So that's why the inverse and the converse are both false. Thanks everyone, and I'll see you in the next video.